All right. We are Team 5. Transportation as a Service is our project, and we're going to present our final deliverable today. So Transportation as a Service is a multimodal route planning application. And at a high level, we aimed to address limitations that are commonly found in route planning applications by allowing users to specify trip plans that may involve multiple modes of transportation for one local trip. So our goal for this phase of the project was to develop a back-end proof of concept model, which is what will be presented today. Our team consisted of myself, Erica Ransom, Frank Ware, and Hudson Topping. So I wanted to speak today on our project management approach. We use the POMA method that we learned in class. POMA, as a reminder, stands for planning, organizing, monitoring, and adjusting. All of these obviously were used in support of the project to ensure that we had effective project management and a successful delivery of our objectives. So as far as planning, we defined our project goals and objectives by outlining our desired functionality of our application. The team early on conducted research on APIs, data sources, and technologies to identify the most suitable tools for our project, and also wrote a project plan including timelines and milestones for our task assignments in order to help guide project execution. From an organizing standpoint, we did assign roles and responsibilities to our team members based on their expertise and strengths. We had stand-up meetings and communication channels, primarily Microsoft Teams, established at the beginning of the project to ensure that we had effective collaboration and coordination. Task dependencies and project deliverables were identified to streamline our workflow. We use sprint planning where necessary during critical development periods, and also use the GitHub repository to establish version control for our Java classes. Monitoring. So we use regular project status meetings to review progress, discuss challenges, and address issues that arose during implementation, specifically for coding development. We also had an external resource familiar with the project audit our meetings a few times to provide feedback as necessary. And adjusting. Throughout the project, we regularly reviewed and evaluated progress and outcomes against project plans. And as the scope deviated or we had obstacles encountered, such as losing a project team member or finding a better or different way to do things, we made adjustments to our project scope, the timeline, or resources assignments as needed. So we were able to effectively use the POMA approach to meet our project objectives. And with that, I'll turn it over to Frank Ware.
Hi, I'm Frank Ware. I'm kind of the brainchild of the project. This is an attempt to supplement Google's Google Maps systems. Currently, the Google Maps systems are limited in the fact that the APIs do not allow a user to use more than one mode of transportation. So for instance, if you wanted to look at all of your different route options of how could you get to work in the morning, you could ride a bike, you could walk, you could do transit, you could do ride share like Uber and Lyft, you could rent a car, you could drive, you could do any one of a large list of different approaches to getting there. Most of them, one at a time, can be mapped through Google Maps, through their Google Directions API, but you're not able to map more than one mode at a time. So our approach technically was to start out with the transit systems maps. The reason for that is the transit systems have fixed locations, and then using those fixed locations, doing recursive lookups through Google Maps to create a geo model of the area. And then the geo model of the area would then be used, from there to figure out how the maps would come out. So this project, rather than being an attempt to actually create the final product, was a proof of concept, so that we could sort out the different issues and challenges that we were going to face as we continue development, and from there uh, begin actual coding on a product, a releasable product. So what this is the back end for the transportation of as a service system. Transportation as a service is basically a look that name reflects the paradigm shift from people owning their own vehicles toward people using rideshare and other services, Uber Eats, for instance, to deliver their food, as an alternative to owning your own vehicles. This is a trend that's already going on. The number of people who are getting their licenses at the age of 16 has dropped significantly. The number of people who have licenses under the age of 30 has also dropped significantly in the last 20 years in the United States. What people are doing is using different alternatives, and this system that we're planning is to help people who don't have their vehicles or don't want to use their vehicle to figure out other ways to get to work, or to get to school, or to get to the grocery store. So with that, I'm going to turn it over to Hudson Topping. He's going to go through the system itself and what we did as far as coding.
Thanks,
So
Frank.
Hudson, yep.
Thanks, Frank. Okay, so you'll go through our the general flow of information, which allows us to create what we wanted to create. So first, this is the parent application, or can you go to the main application? Yeah, there it is down there.
Yeah.
Manage session. This is the parent, which calls everything. So the very first thing we need to look at the goal is multimodal transportation, and we want to shift it according to the values. So could you go to user account? So create a user account with all these writing preferences, what modes are available to them. And then beyond that, even if you have only certain modes available to you, maybe whether speed or money or emissions or whatever is your value, we added that in as well. Could you go to the interface? The interface is, so you have your user account, which has your default settings, and it has some default users for testing or experimentation or whatever, or common uses. The user interface allows you to edit all that, directly, which is good for us. So that's what the application calls. Is the user interface creates a new one. Could you go to route request? So route request is taking in all the information about what the user values and what the user is capable of, and then it adds that with, of course, the destination and the departure locations. And this is what is going to configure this and start making calls to actually get the information from the Google API. Could you go to API connector? So the API connector is what takes the Google, brings it in, and gets the Google, takes the request based on the valuations that route request gave, and then one second, really quickly. Hi, sorry, there's people in my house. Okay, so the API call comes back and my goodness, losing my train of thought here. Okay. It turns that and it makes that a JSON file, but it's critical that the legs and the vertexes that come back aren't actually named perfectly in a user readable way, which is why we use the next file. The weighted graph name generator is another call to the API, which takes in the longitude and latitude, which are easily found from the first API call, and then that converts them to usable, readable names for the vertexes, because this is a weighted graph, so the vertexes and the edges are what make up the weighted graph. Could you go to weighted graph? This is the backbone of it. This is what the JSON returns from the API call are converted into. This is what weights according to all the user preferences. This is kind of, in many ways, this and the API call are the backbone of the project. But we don't leave it as a weighted graph. We want to combine a lot of weighted graphs and get kind of like just a surface layer which reflects everything, which is the next method. That is the geo model. So the geo model is the composition of all the route requests. And this is our output. It is the output, which is the weighted values of all the edges, the vertices, which are common to the user's current needs and reflections. So that's me. Frank, do you want to come online so you can start talking?
Yeah. So actually, I'm going to demonstrate the application then. You'll notice that this is all within the console. Again, this is just a back-end proof of concept. So we were trying to make sure that we had the back-end developed correctly. In order to demonstrate it, we set up 3 different users with their preferences, and then we also gave the option to select a route and origin and destination by typing it in, as well as a general idea about how you wanted us to plan your route. Or you could go through the whole account setup where you go through the preferences that you have for each of the different modes of transportation. So just for demonstration purposes, we're going to use just one of these options, which is the first one. You'll notice that the first thing it does, she wants to go from Memphis Barbecue in Dunwoody to the Amtrak station in downtown. She's selected preferences for bicycling and walking. The application takes just a moment to run. The reason for that is that it's having to call the API repeatedly. When we do the actual application, the intention is to save the geo map in a database so that we don't have to do that. You'll notice that the output shows several vertices. Basically, the vertices are different locations that you might go to on your route. And then it has a series of specific steps from the first vertex to the second, second to third, third to fourth, etc. In each one, it displays the mode of transportation you're using, the distance, the duration, and the cost. And these are basically the steps that you would take along the way. So with that, I guess we're going to conclude the presentation. I want to thank you for listening. Again, this is Transportation as a Service, Group 5, and this is a demonstration of what we've done this semester.
All right.
All right, that sounded good.
Thank you. You can stop the recording.